everyone, I'm Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to solve some problems on network theorems. So first problem here, find the current flowing through the 8 ohms resistor in a given circuit. So here in this given circuit, this is the 8 ohms resistor current. You need to calculate it using Thevenin's theorem. How you will calculate the current in Thevenin's theorem? In normal method, you can determine the current flowing through the 8 ohms later. That means mesh analysis and nodal analysis you can calculate it. But here using Thevenin's theorem. Using Thevenin's theorem. So what are the steps? Steps to follow the Thevenin's theorem first. So here any circuit is replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with resistance, and this is the load resistance R L, and this is the RTH, and this one is the VTH. Thevenin's voltage VTH, Thevenin's resistance RTH, and Thevenin's load resistance. Here what is meant by load resistance? Load resistance means where you want to find out the current. Here 8 ohms current you need to calculate here. So this 8 ohms resistor current is the RL, 8 ohms resistor is the load resistance. Now here, so this circuit is replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with resistance. Now reconnect the load resistance. This circuit and this circuit is same. So now here this current flowing through the 8 ohms resistor. So how you will calculate? So to find out the 8 ohms resistor current, you need to determine the VTH and RTH. First VTH, find out this VTH value. So find the VTH, Thevenin's voltage. How you will calculate the Thevenin's voltage? So first remove the load resistance from a given circuit and calculate the open circuit voltage. So now that resistance that I'm drawing here, the circuit. This is the circuit. So now 8 ohms resistor and 10 ohms resistor, next 5 ohms resistor, next 5 ohms resistor, next to 250 ohms, 250 volts. So now here, what are the steps? Here first remove the load resistance from a given circuit. Step 1 is remove the RL, load resistance from a given circuit, and calculate the open circuit voltage. That open circuit voltage is known as the Thevenin's voltage. Now here remove the load resistance from a given circuit and plus and minus VOC. Calculate this Thevenin's equivalent Thevenin's voltage. So now here VOC, open circuit voltage. So now how we will calculate? So here if you apply mesh analysis for this circuit, let me change the color over here. This is the I1 mesh analysis I am applying. I1 and I2 in clockwise direction. Now here I2 current is 0. So now here, so apply KVL in the mesh 1 and mesh 2. So now here mesh 1, if you apply KVL in the mesh 1, so minus 250 plus 5 into I1 plus 5 into I1 minus I2 equals to 0. This I2 equals to 0. If you apply KVL in this mesh, now from this I1 equals to 250 by 5 plus 5, this one. So now this I1 equals to 25. Next, second case. So now here we need the open circuit voltage. How we will calculate? This 5 into this current. This is the redundant branch. There is no resistive drop because this I2 current is 0. It is in series with open circuit. So neglect this resistive drop, 10 ohms resistive drop. Next here this 5 ohms resistive drop is the VOC. So now here 5 into 25 is a 125 is a. Now otherwise if you apply KVL also in this equation, so this is VTH, we can call it as this is Thevenin's voltage. VTH 5 into I1 minus VTH, next 250, this one equals to VTH 10 and next 75. Where is the 75? This one. 175 minus 5 into I1, that equals to 175 minus 5 into 25, that equals to 50 volts. So now what about the equivalent RTH? This one is a 50 volts. So now what about the RTH? RTH equals, sorry, there is a wrong in this. So now here 5 into 25, this current equals to this 75. Sorry, this 75 is also not. There is a 75 volts. I forgot. Now here, so 5 into this one. This, if you apply KVL in this loop, so this is redundant. VTH minus 75, 5 into I1 and 250. That equals to this one 50 volts. And next, to calculate the RTH, to determine the RTH, first draw the circuit. $250, 5 and 10 and 8 ohms, and this is 75. So to determine the RTH, first remove the load resistance from a given circuit, and voltage sources are replaced by short circuited and current sources are replaced by open circuited. So how this 8 ohms resistor is replaced is open circuited, and this one is replaced by short circuited. This 75 volts is replaced by short circuited, and this 250 volts is also replaced by short circuited. Now here this 5 and this 5 are connected in parallel and again in series with 10 ohms. 5 and 5 connected in parallel, again in series with 10. So now here 5 into 5 plus 5 into 5, that equals 5 plus 5 plus 10, that equals 25 by 10, 2.5, and this is 10, that is equals to 25, 12.5. So now this is 12.5. Now this circuit is replaced by single equivalent circuit. This single equivalent circuit consists of 50 volts in series with 12.5 Thevenin's resistance and this 8 ohms resistor. Now if you apply KVL in this loop, this is the 8 ohms resistor current. That current is the current flowing through the 8 ohms resistor current. So now here, how you will calculate? Just apply KVL in this simple mesh, simple loop, that equals to, so this 50 volts divided by 12.5 plus 8 equals to 2.44 amperes. Next, second problem. Find the current flowing through the 2 ohms resistor connected between AB terminals. See the circuit first. In between AB terminals, calculate the current. So calculate this current. So 2 ohms resistor current. So this 2 ohm, not this 2 ohms resistor current, between AB terminals. So first, same thing here, this circuit is replaced by single equivalent circuit, and that single equivalent circuit consists of one resistance in series with one voltage source. That voltage source is known as the VTH, Thevenin's voltage, and that resistance is known as the Thevenin's resistance, that is RTH, and this is the RL. Here what is the RL value? Here 2 ohms resistor, because we are finding the current, this 2 ohms resistor between AB terminals. So now here, how we will calculate the VTH? To find out the VTH, what are the steps? So first, remove the load resistance from a given network. So draw the circuit first here for that purpose and apply the KVL. Now remove the load resistance first. So this is the circuit. This is the load resistance, and this one, and this one, and next here 2 volts, and this one 2, and this one 12, and this one 1, and this one is 3, and this one is a 4. So now here, remove the load resistance from a given circuit and calculate the open circuit voltage. This is the I1, and this one is the I2, and this one is also I2, because same current flows to I3. You can consider it as the I3, but I2 and I3 is same, so this one is also I3. This current is I2 current I am considering. So now calculate the open circuit voltage using mesh analysis technique. First calculate the VT. That open circuit voltage is known as the VTH. So now here, if you apply KVL in the mesh 1, so this is 2 volts. So 2 minus this is resistive drop, 2 into I1 and 12 into I1 minus I2. So first equation, if you simplify it, 12 plus 2 is 14 minus 12 I2 equals to 2. This is equation number 1. So now what about the second mesh equation? Second mesh equation, apply KVL. So this is, I am considering this one as a single loop. So now here minus 12 I2 minus I1. Next minus I2, 1 into I2, and next 3 into I3, plus minus 4 equals to 0. If you apply KVL in this loop, algebraic sum of total voltages in a loop equals to 0. Now that equation equals to 12 into I1 minus 12 into I1 plus 16 into I2 equals to 4. This is equation number 2. So now this, from if you solve this two equations, you will get the I1 and I2. From that I1, I2, calculate the open circuit voltage, this one. So now here, so solve these two equations. I2 equals to this one. I2 equals to, what is the I2 value? I2 equals to minus 0.4 minus 0.4 amperes. So from this I2, calculate the VOC. How we will calculate that one? So first, so now here if you apply KVL in this loop, so in this loop only I am considering, this is VTH, that means VOC, and 3 into I2 minus 3 into I2 and minus 4 equals to 0. So from this I2 value you substitute here, you will get the value, that is 2.8. That 2.8 volts is the Thevenin's voltage. This is VOC, that means VTH, open circuit voltage. Thevenin's voltage value is 2.8 volts. So now how we will calculate the RTH? RTH can be calculated. So RTH circuit, to determine the RTH, so what are the steps? Remove the load resistance from a given circuit, and voltage sources are replaced by short circuited, and current source is replaced by open circuit. So now calculate the open circuit equivalent resistance between open terminals. That open circuit resistance is known as the Thevenin's resistance. That one is here, this is the circuit I am drawing. So first one is here, this one. So 2 volts, and this one is 2, and this one is 1, and this one is 12, and this one is 3, and this one is the 4 volts. Remove the load resistance first. Remove this load resistance from a given circuit, 2 ohms, and voltage sources are replaced by short circuited. This voltage source are replaced by short circuited, and current. So is there any current source? No current source. So now replaced by open circuit. No need to open the any current source. Now calculate this R equivalent between these two. How we will calculate? First this one. This 2 and 12 are connected in. So let me change the color over here. So first 2 and these 2 are connected in parallel. So these 2 and 12 are connected in parallel. After that, this 1 ohm is connected in series. 2 into 12 divided by 2 plus 12 plus 1. So this is the 1. After that, this entire circuit and this one 3 are connected in parallel. So this one, this is the parallel combination. The simplification is this entire is connected in parallel with these 3, and that one is 1.43 ohms. So that value equals to this one equals to, so 1.43. Now we have the RTH, VTH and RL. So that equals to this IL equals to this 2.8 divided by 1.43 plus 2. So what is the value here? That value equals to, so this one 2.8 divided by 1.43 plus 2 equals to 0.82 amperes. 0.82 amperes. This current is 0.82 amperes. This entire circuit is replaced by this circuit. This current and this current is same. Next, what about third problem? Find out the current flowing through the 3 ohms resistor in a given circuit using Thevenin's theorem. So first problem, so in this, so 3 ohms resistor is the current flowing through the 3 ohms resistor. This circuit is replaced by This is the RL equals to 3 ohms, RTH and VTH, Thevenin's equivalent circuit. Let me change the color. So first here this circuit and this circuit is same. So same circuit. So here this current and this current flowing through the 3 ohms resistor is same. So first here VTH calculation, VTH to find out the VTH. So first remove the load resistance from a given circuit. (6 amperes). VTH calculation, remove the load resistance from a given circuit. So first here remove this load resistance first. How to remove this one? So now here this 6 ohms and 12 ohms and 42 volts and 6 amps. So now here, so first remove this load resistance. This is VOC. Now here mesh analysis. If you apply KVL, so mesh analysis, I1 equals to this 6 amperes. So same thing. And next if you apply KVL in this mesh here, so 42 minus 12, I2 minus I1, and next this one value, this is, there is no resistance here, and this one equals to 6 into minus 6 into I2. 6 into I2. So now here, so this equation minus 12 I1 plus 18 I2 equals to 42. If you substitute in this, you will get the I2 value. So now if you solve this I1 and I2, you will get the I2 value. After that, this I2, this 6 ohms resistive drop is the VOC. That VO6 into I2 equals to, that equals to 6 into 6.33 is a 38 volts. This is the 38 volts is the Thevenin's voltage. After that, next RTH can be calculation. RTH calculation is remove the load resistance from a given circuit. I am drawing the circuit here. So remove the load resistance from a circuit. This is the circuit. There is no resistance here. So now here, remove the load resistance from a given circuit. Remove this. And voltage source is replaced by short circuited. This is replaced by short circuited, and this one is replaced by open circuited. Voltage source is replaced by short circuit, and current source is replaced by open circuit, and remaining elements are only 2 and 6. So these two are connected in parallel. Calculate this open circuit resistance, that equals to RTH. So 12 into 12 parallel with 6 is this one. So now here that value is 4 ohms. So now what about the current? This current equals to this 38 divided by 4 plus 3, that equals to 38 by 7. So that value equals to 38 by 7, that means 5.43 amperes is the Thevenin's resistance. Now next, find the current flowing through the 10 ohms resistor using Norton's theorem. So now here, this one, here 3 voltage sources, 50, 40 and 100 ohms. So 10, 20, 30, 20, 20. Here current flowing through this 10 ohms resistor. So remove the load resistance. So first here, this circuit is replaced by current source in parallel with resistance, and reconnect the load resistance RL. This is the RN, and this one is the IN. So this circuit, entire circuit is replaced by this one. What is Norton's theorem? Norton's theorem, and then this is using Norton's theorem. What is Norton's theorem? Number of voltage sources, current sources and resistors are replaced by single equivalent circuit. That single equivalent circuit consists of current source in parallel with resistance. So that if you connect the load resistance value is 10 ohms resistor where you want to find out the current here. So now here this IN and RN calculations first. So IN calculations first, remove the load resistance from a given circuit, short the load terminals and calculate the short circuit current. That short circuit current is known as the IN. So first I will draw the circuit first. So same circuit I am drawing here, this one, this one, this one, this one, and this is voltage source and this is resistance, and next here 100 volts, and next here this one is 50 volts, 50. So now here remove the load resistance. This is 10 ohms and this one is 20, 30 and 20. This is 20, 20, 100 and next this is the 40. So what is the theorem in the Norton's theorem? IN calculations can be, so first here remove this load resistance and short the load terminals. Remove the load resistance, short the load terminals and calculate this short circuit current ISH. That ISH is known as a IN. So this is IN. So how we will calculate? By mesh analysis or nodal analysis or any network reduction technique, you can calculate the short circuit current. That short circuit current is known as the Norton's current. So first I am applying the KVL here. So mesh analysis here. So this is the I1, this is I2 and this is I3. If you calculate the I1, then that current is the ISH, that is the IN. So now first calculate the IN. So if you apply mesh analysis in the 3 meshes, and you will get the mesh currents I1, I2 and I3. I1 current is the short circuit current. So how to solve that mesh current? So first, if you apply KVL in the mesh 1, so 50. This is short circuit. There is no 10 ohms resistive drop here. So now 50 minus 20 I1 minus I2 minus 40 equals to 0. 20 minus 20 I2 equals to 10. This is equation number 1. Next, second mesh equation. So 40, this one, 40 to minus 20 I2 minus I1 and next 20 I2 minus and minus 20 I2 minus I3. The simplification equation minus 20 I1 plus 60 I2 minus 20 I3 equals to 40. That is equation number 2. Now next third mesh equation. So same 20 into I3 minus I2 and next 30 into I3, this one, and 100 plus 100, this one. The simplified equation is minus 20 I2 and minus plus 50 I3 equals to minus 100. So now if you solve these 3 equations, this is equation number 3. This 3 equation number 1, 2 and 3. If you solve that 2 equations, you will get the I1 value only we need. So I1 equals to 0.81. So this I1 equals to 0.81 means Norton's current equals to this ISH equals to 0.81. This current equals to 0.81 amperes. Now here, the what about the RN? RN can be calculated. Same thing here, like Norton's Thevenin's resistance. Remove the load resistance from a given circuit. Voltage sources are replaced by short circuited and current sources are replaced by open circuit, and calculate the open circuit terminal volt resistance. That resistance is known as a RN. So now here, so I am drawing the circuit. So remove the load resistance from a given circuit. First here, this is the circuit. So now I will draw the 20, 30 and 100, and this one is 20, 20, 40 and 50. So let me draw the, so remove the load resistance, sorry, this is 100, okay. This is replaced by short circuit. Remove the load resistance from a given circuit, 10 ohms, and this is replaced by short circuit. Voltage source is replaced by short circuited, and this is replaced by short circuited, and this one is also replaced by short circuited. Remove the load resistance. So remove the load resistance. This is open circuit terminal voltage. Calculate this R equivalent between these two. Remove the load resistance from a given circuit, this one, and voltage sources are replaced by short circuited, and calculate that one. So now here in this 20 and 30 are connected in parallel, and again in series with 20 and again in series with parallel. So see that. So 20 and 30 are connected in parallel, again in series with 20 and again in parallel with 20 ohms. So that value is 12.33 ohms. That is 12.33 3 ohms. So now what about the current? If you apply current division rule here, this is 12.3 ohms. So now here we need the current flowing through this 10 ohms resistor. So now here if you apply the current division rule, total current into, so 0.81 total current into opposite branch resistance 12.3 divided by total resistance 12.3 plus 10 ohms resistor. So what is the value here? Total resistance, total current into opposite branch resistance divided by opposite branch resistance plus same branch resistance, that means total resistance equals to, that is 0.45. This current equals to 0.45. If you use mesh analysis, if you use nodal analysis, if you use Thevenin's theorem or any superposition theorem, if you apply any technique, you will get the same value. That value is 0.45. Using Norton's theorem, current flowing through the 10 ohms resistor equals to 0.45. Now, next problem, find out the current flowing through the 10 ohms resistor using this 10 ohms resistor using Norton's theorem. Same thing, Norton's theorem. Current flowing through the 10 ohms resistor. So now here, so first one, remove same thing. So I am drawing the circuit. This current source Rn and In. This is the RL. What is the RL? Is the 10 ohms resistor. In and Rn you need to calculate it. So first I am drawing the circuit. So first circuit, to find out the In first. In can be calculated. So first this one. This is 15, 5. There is a resistance. This is just 5 and 1, 2 volts, and this one is 10 ohms. So now here remove the load resistance from a given circuit. Remove the load resistance from a given circuit and short the load terminals. Calculate that short circuit current ISH. That is important. Remove the load resistance from a given circuit and short the load terminal, short circuited. So, and that short circuit current is known as a IN. This one. Now, how we will calculate it? So, first this is I1 and this one is a I2 and this one is a I3. So, now here there is a super mesh in between two meshes, one current sources exists. So, that by mesh analysis you can calculate it. So, first here IN calculation. So, first here I2 minus I3 minus I2 equals to 4. Is it okay? So, this I2 and I3. So, I3 minus I2. Why? Because I3 current and this 4, if you apply KCL, it will also satisfy. Sum of entering currents equals sum of leaving currents, or this I3 current direction and this 4 amps current is same. So, I3 minus I4 is a I3 minus I2 equals to 4. This is this one. This I3 minus I2 equals to this 4 amperes. So, this is important. Next, the second case, this is short circuited and this one is short circuited. 2 minus I1, 1 into I1 equals to 0. This is if you apply KVL in the mesh 1. So, now that equals I1 equals to 2. This I1 equals to 2. Now, here we need I1 and I2. I1 minus I2. I1 minus I2 is the short circuit current. So, here we need I1 minus I2. So, to get the I2 value, so apply KVL in this mesh. So, now here 5 into I2 and 15 into I3. That is equation number 3. If you solve these 3 equations, you will get I1. I1 already is 2 and I2, I3. So, I2 is minus 3 and I3 is 1. So, now here ISH equals to this ISH equals to I1 minus I2. ISH means that is IN, I1 minus I2. What is I1 here? 2 and I2 is the minus 3. So, that value is 5 amperes. So, now this is the 5 amperes. Let me change the color over here. This is the 5 amperes. So, now here Rn value, same Rn value, remove the load resistance from a given circuit. So, I will draw the circuit first here. So, drawing the circuit is difficult. This is the circuit. So first remove the load resistance 15, 5, 10, 1 and 2 volts. So remove the load resistance from a given circuit. So calculate the open circuit voltage, and voltage sources are replaced by short circuited and current sources are replaced by open circuit. This current source is replaced by open circuit. Calculate this R equivalent. Remove the load resistance from a given circuit. Voltage source is replaced by short circuited and current source is replaced by open circuited. Now calculate the equivalent resistance. Here is the 1 and this is 5 and 10. So now here these two are connected in series. 5 plus 15, 20 and this is 1. And this 20 and 1 are connected in parallel. So see the equation. This 20 and 1 are connected in parallel. That value equals to 0.95. That value equals to 0.95. So now here current division. So how we will apply the current division? 0.95. So now this current we need. Current flow into the 10 ohms resistor. So now here total current is 5 amps and opposite branch resistance 0.95 divided by 0.95 plus 10. So this value. So this equals to 5 into this one. Total current and 0.95 this one and 0.95 same branch resistance and opposite branch resistance addition, that equals to 0.43. This is 0.43 amperes. 0.43 amperes. In this way we can calculate the current flow into the 10 ohms resistor using Norton's theorem. So now next problem, find the current I and verify the reciprocity theorem. So reciprocity theorem means, what do you mean by reciprocity? State the reciprocity theorem. So when you interchange the source terminal and branch terminal, the ratio of response to the excitation is same for both the networks. That is the reciprocity theorem statement. So first, this is the network. This is the current. This is the response, I current, and this is the supply voltage excitation. And next, if you interchange the source, this is the same again in a linear bilateral network. This is the resistance and this one is the resistance. Let me change the color. This is the I and this one is the E, and this is the I dash and this is the E dash. The ratio of response to the excitation is same by excitation of this one. This, if it is satisfies, then reciprocity theorem is verified. Reciprocity theorem can be applicable only for single source network. For this network, verify the reciprocity theorem. It can be applicable only for single source network. So it is only having single source network, and it can be applicable only by linear bilateral network. So now it is a linear bilateral network. All elements are linear bilateral elements here. So first here, so now here what is the response and excitation here? This is the excitation E and this one is the response I. So this is excitation E and this one. And next ratio. After that, interchange the voltage, this E1, this current should be here and this 55 volts should be here. So now here, so first calculate the response for this circuit 1 and then second circuit I will show you the next. So first here apply KVL. I1 and I2 and I3. So now here 5 into 5, 2 into I1 and 3 into I1 minus I2. Next 4 into I1 minus I3. So now in this, if you apply KVL in this mesh 1, so now this is the equation, mesh equation. That simplified value equals to, the equation equals to 9I1 minus 3I2 minus 4I3 equals to 5. That is equation number 1. Now if you apply KVL in the mesh 2, mesh 2, this is mesh 2, this is mesh 2, I2 minus I3 into 3, this one minus 3, and 2 into I2, and next 3 into I2, this one. So now here this is equation number 2. The simplified equation is minus 3I1 plus 8I2 equals to 0. Now here this is equation number 3. 4 into I3 minus I1 and next 4 into I3. So this is equation number 3. If you solve these 3 equations, you will get the I1, I2 and I3. But here we need this current I only. This current is here this current is here I3. I3 current is this response current. Response current is the 0.4 I3. So this current is 0.43 amperes and this one is a 5 ohms. So 0.043 by 5. Now second circuit, when you interchange the source terminal and branch terminal, source. So source should be here and this both should be interchanged. So this is 5 and this is the 1. So now in this case, so now same thing, apply KVL in the mesh 1 and mesh 2 and mesh 3. Mesh 1, 2, 3. So now here, so minus 2 I1, same 5 is 0 here for 2 into I3, 3 into I2 minus I3 and 4 into I2 minus I3. 3 into I2 minus I3. That simplified equation is 9I1 minus 3I2 minus 4I3 equals to 0. That is equation number 1. If you apply KVL, same equation is here. 3 into I2 minus I3 minus 2 into I2 and 3 into minus I2. That is all or minus. That simplified equation, same thing here. Minus 3I1 plus 8I2 equals to 0. So now third equation, same thing here. If you apply KVL in this loop, 4 into I3 minus I2, I1 sorry, this one, and plus 5 and minus 4 I3. That simplification equation is 3 minus 4 I1 plus 8 I3 equals to 5. If you solve these three equations, you will get I1, I2 and I3. Here is the I1 is the this response current, the same value we got here. This one, this current and this one. This is the excitation. Here excitation is 5, this excitation is 3. Same value. Now that current I value is 0.43 and reciprocity theorem is also verified. Now, find the network. For a given network, find the value of RL maximum for maximum power and calculate the maximum power. This is the network. So this RL value, how we will calculate RL value? When load resistance equals source resistance, then maximum power transfer theorem. For maximum power, so RL calculate. So we know the statement, when load resistance equals source resistance, then maximum power transfer to the load. So that statement I will use here. This is the circuit. This is the RL, this is the RS, and this is one is the VS. When load resistance equals source resistance and then maximum power transfer to the load, here is a P maximum. So this circuit, this entire circuit is replaced by this single equivalent circuit, voltage source in series with resistance and load resistance. Load resistance value you need to calculate. So first, equivalent resistance. So RTH, RS can be calculated using Thevenin's equivalent resistance. So first here RS, so first here. So RS and RTH. So first I will calculate the maximum power, VTH. So this VS I will calculate. So first VS, how you will calculate? Remove the load resistance from a given set. Remove this load resistance and calculate the open circuit voltage. So first for that, so first I will draw the circuit here. This one, this is the current source and this one is 8 volts, 2 and this one is 2 and this is 1 and this is current source and this one is open circuit and this is 2 and this one is 6 volts. So now here if you apply KVL in the each mesh, this is I1, I2 and I3. So now here I2 minus I1 equals to this 2. I2, I1, I2 and I3. I2 minus I1 equals to 2 and I2 equals to, I1 equals to, what is the I1? I1 equals to minus 5. Next, here VTH calculation, I2 minus I1 equals to minus 2 and next I3 minus I2 equals to, I3 minus I2 equals to, this one equals to 3 amperes. But I2 equals to, what is I2? I3 value is 0. I3 value is 0 and I2 equals to minus 3. this I2 equals to minus 3. And from this I1 equals to minus 5. Same here. So I2 minus I1 equals to 2 and I3 minus I2 equals to 3. So now here this I3 value is 0 because it is a open circuited. This current is 0. So now here I2 equals to minus 3, this one, and I1 equals to minus 5 from this. So now here if you apply KVL in this loop, so now here how you will, so all are super meshes here, 8 into 2 into I1 and next 1 into I2 and next this is VOC, VTH and next 6 into I3 and this resistive drop. And now here from this VOC equals to VTH equals to VS equals to 15 volts here. So now here RTH calculations can be, remove the load resistance from a given circuit first. So now here 2, 1 and 2. So now remove the load resistance from a given circuit and voltage source is replaced by short circuited. This voltage source is replaced by short circuited and current sources are replaced by open circuited. And these two, 2 and 1 are connected in series and again in series with 2 plus 1, that means 5. 5 is the R. This is the 5 ohms resistor. 5 ohms resistor is the RTH. Now here when load resistance equals to, this source resistance is 5 ohms resistor. Now here for this maximum power, this RL must be 5 for maximum power. When load resistance equals source resistance, then maximum power transfer to the load. Here this load resistance equals to 5 ohms for maximum power condition only, maximum power transfer condition only. That maximum power value equals to Vs square by 4 RL or 4 RTH. So this is 15 volts divided by 4 into 5, that equals to 11.25 volts. Next problem. For the network, find the value of resistance, maximum power and calculate. So first this is the network. So here you need to calculate this RL. How you will calculate? So first here this one, this resistance, so RTH. So for the maximum, this circuit is replaced by Vs and Rs. This is the RL. So RL you need to calculate. So from the maximum power transfer theorem you can calculate the Rs. So Rs you, so now here Rs can be determined. So first this is the circuit. (10), 5 and this is 6 amperes and 120 volts. So now here remove the load resistance from a given circuit. This is R equivalent you need to. And current source is replaced by open circuit and voltage source is replaced by short circuit. Voltage source is replaced by short circuit and current source is replaced by open circuit. Calculate this R equivalent. So this, in between these two are connected in parallel. 10 and 5 are connected in parallel. So the circuit, it looks like this. 5 and 10, these two are connected in parallel. So that value is 3.33 ohms. This RL value is 3.33 ohms. So now what about the maximum power? Maximum power can be calculated if you know the Vs only. So maximum power equals to, that equals Vs square by 4 RL. So here 4 RL means RL value, we know this RL equals, according to the maximum power transfer theorem, this one is 3.33 and Vs can be calculated using mesh analysis. So first remove the load resistance and calculate the open circuit voltage, that means VTH, that means Vs. So now here apply KVL in the mesh 1. So first here I1 and I2. I1 and I2 is same. I3, I2 is here. This current, same current. Here there is a open circuit. There is no current here. Same current flows here. Now here 120 and 10 into I1 and next 5 into I1 minus I2. Next, this I2 equals to this is upward direction and this one is the downward direction. This is minus I2 and 6 ampere current source is opposite direction. I2 equals to minus 6. If you substitute in this, you will get the I1 equals to 6 amperes. So now here VTH, if you apply KVL in this loop 120, 10 I1 and plus VTH, that equals to, if you substitute in this, you will get the VTH equals to 120 minus 10 into 6, that equals to 60 volts. 60 volts. Now here maximum power equals to VTH square divided by 4 RL, 60 square by 4 into 3.33, that value equals to 270.27 watts. So now here third problem, for the given network find out the value of maximum value. Now here same procedure, same circuit is replaced by single equivalent circuit. That single equivalent circuit consists of one voltage source in series with resistance, source resistance, source voltage and source resistance and RL. So here RL is you need to calculate it according to the maximum power transfer theorem. So how you will calculate? So first remove the load resistance from it. Where is the load resistance? This is the load resistance. So I am drawing the circuit here. This is the circuit. This is the current source. Remove the load resistance here. Remove the load resistance from a given circuit and voltage source is replaced by short circuited and current source is replaced by open circuit. And this is 25 and this is 10 and this is 6. 10 plus 6 are connected in series and again in parallel with this one. That value is 25. 25 is parallel with 16. 10 plus 6, that is 9.76. So RS is 9.76 means at the maximum power condition, RL value equals to, according to the maximum power transfer theorem, when load resistance equals to source resistance, that value equals to 9.76. Now here how we will calculate the Vs. So if you know the maximum power equals Vs square by 4 RL value is this one. Vs can be calculated using Thevenin's voltage calculation procedure. Same, remove the load resistance from a given circuit. Remove this load resistance, this is VOC. So now this is a I1 and this is a I2 and this one is a I3. I1 current is 0. Sorry, this is they are considering as a I1 and this is the I2 and this current is 0. In this loop current is 0 because it is an open circuit and this current equals to I1 current equals to I3. Now here if you apply KVL in this loop, so minus 25 I2 minus I1 minus 10 I2 minus 6 I2 equals to 0 if you apply KVL in this loop. So minus 25 I1 plus 41 this in this loop. 41 I2 equals to 0. If you solve these two equations 1 and 2, you will get the I2 equals to 1.83. So now here if you apply KVL in this loop, so V20 plus VTH plus 25 into, so plus VTH, next 10 into I2 plus this 6 into I2 equals to, this one equals to. So here if you substitute I1 and I2 in this, you will get the 9.28, 20 VTH and this one is 25 into, so same drop, this drop and this drop is same. Now this value is 9.26. So now this Thevenin's equivalent power P maximum equals to Vs square by 4 into RL. So that value equals to 2.21 watts. Now next superposition theorem for the given network. Same maximum power transfer theorem. Here three problems we are solving. So same thing here. So first calculate the VTH, Vs. So this is I1, this is I2 and this one is a I3 and this one is a I4 current is 0. So now here remove the load resistance and calculate this open circuit voltage. So I2 minus I1 equals to 1, and next 5 into next here next in the last one 5 into I1, 5 minus here 5 minus I1 into I1, and next minus 10 into I2 minus I3. This is equation number 1 over equation number 2. This, if the simplified equation is I1 plus 10 I2 plus minus I10 I3 equals to 5. In the mesh 3, so minus 10 I3 minus I2 and 2 into I3 minus, that is 3 into I3 minus 3 into I3. Thus equation is minus 10 I2 plus 10 15 I3 equals to 0. So now here, if you solve these three equations, you will get the I1 equals to I2 equals to I3. So this I4 is 0. So now here I3 into this 3 value is known as that. This is redundant, no resistive drop across 5 ohms. So this, that is VOC. I3 into this one into this one, that is 2.76. So Vs square by 4 RL. So now here Vs, this is Vs, and next RL can be calculated. So now here how we will calculate the RL? So same thing here, same circuit. Remove the load resistance from a given circuit. Voltage source is replaced by short circuit and current source is replaced by open circuit. There is no one. And these two are connected in parallel. So 1 in parallel with 10 and again in series with 2 and again in parallel with 3 and in series with 5. That value is 6.48 ohms. So now here Vs square, this 2.76 whole square and 4 RL. RL is a 4.75, that is 0.29 watts maximum power. Next, superposition theorem. Find the current flow into the 4 ohms resistor. 4 ohms resistor. Find out this current flow into the 4 ohms resistor. So now here, how many sources here? Total response equals to sum of the individual responses according to the superposition theorem. So now here, how many sources? 1, 2 and 3. So first source, only one source is active. This is 5 amps. This is 5 amps. So next, here 3 responses. So now here, response 1, this is total response I4. I4 can be calculated using mesh analysis, nodal analysis, anything you can calculate it first. So how you will calculate 4 ohms resistor? Using superposition theorem. Superposition theorem. So this one, when 5 amps active and this 2 amps and 6 volts deactive. Deactive means this is 0 volt and this is 0 amperes. So now this is 0 ampere open circuit and this is short circuit, only 2 and 4. This one. And next here 2 amp active, 5 amp and 2 amp 6 volts deactive. Deactive means this is open circuit and this is short circuited and this is 0 volts. And next 6 volts active and 2 amp and 5 amp deactive means that is open circuit. Deactive for current source is deactive means that is 0 ampere, that means open circuit, and current voltage source is deactive means that is short circuit, that means 0 volts. So now here this is individual response 1 I dash, individual response 2 I double dash and individual response 3 I triple dash. If you add these 3 you will get the total response. So now here how we will calculate? By using current division we can calculate this one. So total current and 2 branches opposite. Total current is this one, opposite branch resistance is 2 and total branch 2 plus 4 is this one. So this current is 1.67 amperes in downwards. And next here is also same current division. If you apply same thing, our total current and opposite branch resistance 2 and this one 0.67. And next in the same in the simple loop, so 6 by 2 plus 4. So this one 6 by that one is minus 1 amperes. So now if you add these 3, you will get the total response I dash, I double dash. According to the superposition, total response equals sum of the individual responses. So now 1.67, 0.67 and minus 1, that is 1.34 ampere, that is downwards. Now, I hope all these problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.